Okay, so this time around we are embracing the practical phase. I'll start by taking you through the MySQL workbench environment where you see what we'll be doing henceforth after the slides I just presented. So when you open your MySQL, by opening MySQL, you just search here for workbench. This word workbench, you just go to your search bar, type workbench, click enter for those who already have it installed. So when you open the registration process that you did, you created a local user with the name root, which MySQL is running in a port call in the port number 3306 in your machine. So when you open, you have this, you click here, you see it opening as it does like that. So when it opens by default, you see it presented the way you have it here, an empty window, and with this side navigation bar, with this bottom environment where the results for a success or a failure is displayed. You can as well close all this by navigating to this side, close this, or below close this side. You can have the window like this, but prefer the window to be like this so that we can see our result and they will see what we are targeting. In that case, we have to navigate through the system so that we know what exactly means what. So we start by going to files. So on files, you can create new models, you can create new query tabs. For instance, this is a query tab, like this query 1 is a query tab. You can create new query tab, open existing models, open SQL scripts that you have already written, open the recent, or for instance the recent files you have been working on. You can run SQL scripts, close connections. These are connections to the server. This is the server here, so you can close connections to server and so on. You can save and exit all this. Go to edit. In edit, you can do undo, redo, cut, copy, paste, delete, select all this stuff you know about them. Then you can go to home. Home basically have what? Select next main tab, select the previous, or use the shortcuts. Query, you can do execute all or execute the selected. Same thing, execute the current, execute current statement, which is where your cursor is blinking, and then explain the current statement. All this basically is summarized and kept in this small bar, or what is found under this query. All of them like this, they are here. So we'll not be coming here to come and do, rather they are all here lined up together. So we have a database, so you can as well connect to multiple data sources. You can manage those connections. You can do reverse engineering. If you have a database, you don't have a code, you can do reverse engineering. Then we have the schema, and this schema here is basically multiple tables that are linked together. That's what they call a schema. And the schema is found in a database, even though those words are used interchangeably, but schemas alone can be considered as database. Let's say you just have a group of 2 tables connected together, then that can be all about a database as well. There can be multiple tables linked together found in the same database. So we have server. The server is just some configurations like what we did during installation. If you go here, you'll see they are mainly showing you the status of the server. If the server is connected, you'll see it running. If there is traffic, you'll see all those things will be displayed here to show that the server is active. You see the host name, you see the socket, you see the port number, you see all this. You see server running, CPU load balancing, traffic, all this. So all these are basically not really important. Just say let me walk us through the system so that we know what is actually what we need to target. And then coming down here, You can also create an SQL tab rather than going to settings to come here and create a tab, query tab here. You can basically just click here and the tab will add here. As well, you can create a folder to be creating your tabs inside the folder. You can also come here to inspect whatsoever you have written here. You come here to inspect it. You can create a database by clicking here. Then you fill the name of the database, take enter. You can create tables in the database you have created here. This is where you click. And then you can move on to create schemas, meaning that what you can link the database, the tables that you created here by using this one. That's connecting them. Now, this one you can create procedures. Procedures are like SQL codes that carry out a particular activity. For instance, let's say you have an already existing database and the users are using your software, the data is syncing in the database, and you have maybe a particular SQL code that you have already written and kept, that whenever you run it, they show you the state of your business, the state of products, maybe state of customers at a particular point in time. So you can store those procedures here. Maybe you are running them monthly or yearly, and then when you run them, you see the output, and then you make a decision and then you proceed. You can keep them. Also, you can have them as functions, just like that. And as I said, here is just a summary of what we had under query, which means here you can still have a folder that keeps all the records of what you have written in the editor here, like what this one does. This is basically you want to save anything you have written in this window. Click here. This means you want to execute, you want to run anything that you have written here, and this means you want to run only what is currently in the active cursor where it's blinking. That you want to run a single line where your mouse is clicking, and this means you want to execute at the same time explain what is written in this entire window. And this is that when the program is running and it meets an error, it should stop. That's the work of this one. This one means when it is active and it runs and meets an error, it should continue after the error. Meaning that if there is, let's say the feed line has an error, but from the 6 downward, it is okay. It should indicate that line 6 has an error but continue rather than stopping. This one says stop. This one says when you meet the error, you should indicate the error but you continue. And so on. So coming to this one is just showing you that you can have as many rows as possible, or you can just say don't limit, meaning that as you put the data, just keep entering, or you can limit to 50,000, depends on you. So basically when you open your MySQL, you will not see most of this. You may see something like Circular, Southwind, Sys, and Well. Things like this training and databases that I created just of recent for testing and training sake. So you can basically just drop all of them just by clicking the drop schema. Right click and take drop schema, take yes from now, and database goes. You can drop all the ones that I don't want, but basically we'll be looking at the Circular. We'll be using Circular for our classes. Believe that everybody that has MySQL installed will normally have this Circular database installed in their system. So so for further explanations about the environment, you will see something like this administration, which is basically what we saw in the saver. So if you click on administration here, you see similar things like the server status, the client connections, and all these user privileges, the data import, export, which is basically similar to everything that we saw as server connection is concerned. Now this is a refresh button, so if you do something here like create a database, it doesn't appear here. Just come and click this small button, refresh, then you will see the database appear. And as I said about this window below, this window, when you see this, it means that what you have done up here is successful. If you see an X, means what you did is a fail. So for instance, we want to say, let's just say you say create database. It's a new DB. It's the name of your database. So create database is an SQL command to create a database. So the name of the database is new DB. So if I execute this, you see here they say create database new DB, and we get it. Now if I run this command again, they give me an error. The error says can't create database new DB, new database exists. So the command failed because they already have new DB. And if you check very well here, you have not seen any database with the name new DB. So we just refresh this and you see new DB here. That's how it goes. So this new DB right now doesn't have any data inside, neither does it have tables. Now how do we put data inside this new DB or tables? Because tables are basically like Excel sheets. We have rows and columns. So first you need to use the new DB. Say use new DB. When you enter this command, everything you are writing under below is being understood to be written in this database called new DB. So if you execute this, you see they say you are now using new DB. Now you can create a table inside our new DB database. Create table, and the table name is new table. You say table, let's say ID is an integer. The ID is an integer, and let's say it's considered as a primary key. As I mentioned in the slides, primary keys are basically uniquely identifying the rows of each column in a table, so that a user should not have the same identification as another user in a particular table. So primary key is the ID. So we say primary, or rather let's make the primary key to be auto incremented, so that when a user comes and enter a name in the table, the primary key should automatically be updated rather than the person entering, because you may enter what has already been entered. So we say auto increment, and we indicate that it's a primary key. Comma, you can go now by saying the name, which is text. So in this case we can say maybe voucher, and they will give you the size, let's say 25 characters. So names should not exceed 25 characters. You can increase them. You can go on to say description, or maybe DOB for date of birth. Then we say date. Can move on to say description or whatsoever. So this is just an example of how a database table is structured, depending on the kind of data that you want the users to be storing as time goes. So you have a table like this, and you discover that on this table, basically what have we said? We said the name of the table should be new table. So this command, create table, stands remain like that. You use in any table you want to create, you must use this tool if you are writing the SQL, rather than using this button where you just click and then you enter the name of the table. So if you are using this, you write this, you write a name, you open this bracket, and in this bracket it is like an array in here. Yes, it's like an array. The difference is just that the array is not like that of Python, where you have an array ending with the right angle brackets. No, this one is normally the round braces. So basically you give an ID, which means any entry of data that is entered into this table should have an ID, and the ID should be different from the previous record, and then with the name, the date of birth, and the description. So the data type here is integer, which means they are real numbers. The name here takes characters, which means it is text, and this varchar means the text can be mixed with numbers. The date normally takes a date format. Yes. The description here is text, which means there is no numbering entered into that. So we want to run this command now, but we don't want to run this one. Remember, if we just come and click here, they will run this, and run this, and any command that they want to run for the second time will give an error like this, since they mentioned here that our database already exists. So how do we do? You can highlight this, and they will run it here, and create our table. So if we come here now, we refresh this, we will see our table created. New table. In our table, we will see the row, the columns, ID, the name, the date of birth, the description. Yes. So basically that is how database tables are created. But you can as well, as I said, create a database table by clicking here. If you don't want to write the SQL code, click there. You will see this. What is the name of the table? You can just say student. Say student table. So what's the first name, column name of the table? You say student ID student. The data type is an integer. It is a primary key. You check this box for primary key. It is not null. Not null means that the value must be there. You can say it is unique, or this. You can say it's auto incremented. Just like that. Go to the next column. Say student, maybe student name as the next column. Is varchar. You can allow the size 45, and then you say this should not be empty. You can move on to the next. Let's say maybe student's age. Student age. Student age, the data type is not this, so you click here, they give you all the different data types. Yes. So student age is what? Age is a number, so you click an integer. Is the age later too important? If it is not, you can say it can be left empty. But if it is later important, you ensure that it should not be empty with the not null constraint. Yes. Move on to the next column. So in this column, you can say maybe description or whatsoever, or place of birth. Let's say place of birth. So place of birth is normally a string, and then it can be left out no. So let's just say that's it for this table. Now when you want to save this, what do? You just take apply. That is all about the table. You just take apply. They show you now the SQL code for the table that you want to create. You see they say create table. The name of the table is what? New db dot student. new DB is the name of the database, so they are telling you that you go inside the database called new DB, you create a table called student. That's why you see this dot. Yes, this is because remember when we were here, so we ensure we run a command to use the database before we create a table. So this one now, if for this script writing to understand the database, they need to first of all call the database name before they reference the table that they want to create inside. And then you see the student ID, the name, the age, the place of birth, and you see their data types: integer, character, integer, character. And they are telling you that the student ID is the primary key. That's why they put it here, and then they are indexing it in ascending order. So each time another record enters, the primary key increase ascending order, and it is visible. So you take apply. Now they apply, they finish. Now if you refresh this, you will see another table has basically added here called student table with these columns: student, this and this. So you can create tables using this approach as well. You can create tables using this approach. Manually write out the SQL code to create the table. But inserting data into a table now, let's say this is a table. Come here, click on this table, they show me the table is empty. Yes, it's empty. It's just showing me the student ID, this and that. How do I get data here? You can as well go to write the data, that insert data into, come up here, start write insert into student, and you start inputting the data, writing the code to input the data one after the other. Or you can as well export this structure. Just come here, come to this, click on this, you just say student, take student, let's say I put it in music, I save the file in music, I take save. So I've saved this empty structure. I can go inside my machine now where I saved it. Let's say I come here, I saved it in music. So the name is student. I open it. So as it is opening, it's basically an Excel document. As you can see, it's an Excel document. So go and fill the data in Excel. Basically fill in anything that wants it to be there in Excel. That's it. It's an Excel document. Come here, I enter student ID, let's say 1, ID 2, 3, 4, 5, 6, 7, 8, 9, and the 10. Let's see, that's the ID that you need to identify every student. And the name, you just say man, woman, child, son, boy, girl. So you randomly, it's just for test. So I just want to show how, if you want to avoid, if you are the one to insert data into MySQL so that you run your queries, this is the process that you embrace. So you can as well input age just like that. So date of birth, since is it date of, yes, date of birth. Since we agree that everything that we have here should not be left empty, all these 1 2 3 4 are not to be left empty. That's why they are found in this table. Those things that can be left empty are not here, like the description that we say it can be no. So the description is not populated in the Excel document. That's why we have a document without description. The column for description is not here. But for place of bed, now you can just write, I don't know, anywhere. Just say anywhere is actually the place of bed, because it's not supposed to be unique. But the only thing constraint is that it's not supposed to be empty as well. So we have this as data for student. If we just save this, let's say save. So we have saved this. We go back to our MySQL environment. Now we can directly import the data into this environment and then start doing whatever we want to do with it. How do we import? We come here, click here, browse. That's it, student. Click open. Take next. Take next. Take this. Take next. Take next. Take next. Finish. So now this is the success message for it. If you come here, we refresh this, come to student table, click this, you see what our data. So if you don't want to have the stress of sitting here inserting rows by writing SQL code, you can basically create the table here, export the table to where you want to comfortably input your data in the database, and then you do it. But most of the times data scientists don't input data. I'm just giving an alternative. Most of the time they come and meet data already existing in a database, and they will have to make meaning out of it using queries. So that is just how to get data into a database using the Excel approach. If you are not using the SQL writing. So we will basically follow this table of content henceforth. I believe by now at least we can navigate through the entire MySQL environment, know our way around. We can export by import. Now we'll start by basic SQL syntax. Go to data types. So we'll be making use of them. I've already mentioned some couple of data types. Later on, go to operators like the equal to, the less than, the greater than, all those. Go to filtering and sorting. Go to aggregation, joins, subqueries, window function, advanced analytics, date and time functions, string functions, JSON operations. That is our program. Okay, we'll be starting with simple select statement. Select statement basically means you want to select something from somewhere. Like this statement here is a select statement. They have mainly said select star means everything from where, from this database, in which table, this table called student. So when you say select star from new DB is this database, and then dot student is the table name. And if you don't want to be using this dot operator, you can remove these. But what will you be using? You ensure that before you use any table, you use the database first. You ensure that you use new DB. When you write this statement here on top like that, then this one is valid, and this one already understand that we are using this database, else you must come and mention the database before the table. So as I said, in our practice we'll be making use of the circular, this one. So I can basically just close this window, close this window, close this window, close this window, and maybe I close all this, so that we start with one of the circular database. So our first thing to do is to ensure that we use circular. So use circular. Every statement ends with what? Semicolon. So we have already run it. So anything we are writing under here now is we are ensuring to use circular. Now since we don't know the tables in the circular, we can just say show tables, and then we run the command. They show all the tables are found inside circular. That is, those are the tables inside circular. Let's say we want to know all the customers that are found in circular. You can come here, and then we say select. Since it's all the customers that we are focused on, hash or star rather, from customer. We run that. Now they give us a list of all the customers that are found in the circular database, especially in a customer table. This is when you want to know all of the customer, all you want to see the record of all of them. You see the record is really quite long. Yes, the record is long. So in a case where you want to have a specific, let's say you don't want the customer ID, or you want just the customer ID, the name, the first name, the last name, and the email. What do? You don't use star again. You say select customer ID, comma, first name, last name, and email. From where? Customer. So it means that address and active and all this will not be there again. This is all that they will select, and the store ID will not be there. So if you run this, you should see just the customer ID, their names and their emails, like that. So in this case now you have figured out the particular columns of the customer table that you are interested in. Now as well, you may want to do another select statement, which says select all what we have selected here. Yes, let's say we are going to select all these, and then order by address. Yes, let's say I just duplicate this. What do we want to accomplish in this command? We want to order the address of each customer in a descending order. That's basically what we want to see. We want to see the customers presented in a list ordered in a descending order. So what do we say? We say select the same. We want this column of customer ID, first name, last name, email, but they should be ordered based on what? The address, and the address should be in which order? Descending or ascending order. That depends on us. So we say from customers, then we say what? Order by order by what? Address ID. Address ID. Then descending order, DSC. So if we run this command now, you see these customers are ordered by address ID in a descending order. Now it doesn't make meaning because you don't see the address ID. So how do you see it? You can just take this and then you add to this. Then it mainly means you will see now the customer ID, the first name, the last name, the email, and the address ID column standing down here. So if you run this again, now you see the address ID starting from the biggest address ID instead going down to the smallest. Get the point now? So we are ordering customers in a descending order, based on what? Address ID. If you want to order in ascending order, you can as well just remove this and put A. Then is a command. Now you see address start from address number 5 rather than number 605. So now it is an ascending order of customer. Everything here is ordered now based on address ID ascending order. Then we also have you can order several things in different orders. Rather, you can say you order customers ascending order. You order maybe date of birth. Let's say the customers table has a date of birth. You can also order the date of birth in descending order in the same query. You can order this like this, and then you go and check the structure of the customer table. You discover that the structure says we have the store ID, the first name, the last name, the email, the address. Now we have already used address to order customers in ascending order. What if we use ID, customer ID, to order them in descending order in the same query? What will become of our result? So you can come here, just put comma, customer ID, customer ID in descending order in the same query. Basically, yes. So the ID of the customer now is ordered in descending order, meanwhile the address is ascending order in this query. That's just for select. So what are the key SQL syntax we have used here? Basically, I'll just use the select, the from, the order, and the ascend, descend. That's basically what we have used. We can also make use of the distinct. Excuse me, please. It says select distinct. What do you want to distinguish in customer? Because it select distinct. What? Just say email from where? Customer. And the statement ends there. You just want to see distinguish something. You just want their emails. Let's say you want to take them and do forward some message to customers. Just distinct. There is no select, or I'll just say select distinct. What? Email from where? Customer. and you move forward. So those are just some simple select statements. So we'll be seeing more as the class continues. Okay, so as I was saying, that's it for distinct. You want to distinctly fetch data, maybe just a single column in a database, maybe just customer numbers. You want to get just the numbers that customers use when they purchase product. You can use this thing and then you figure out, you just fill that out, just a single field in the database with respect to whatever you want, and you can export it. So let's take another example. Let's say we come into the circular database again. Maybe we want to see everything concerning films. Say select start from film. Select start from film. So this error here is because there is no semicolon here. So if you add a semicolon, the error goes, since every statement ends with a semicolon. So you have all the film data rendered like that, complete. So now you can start doing your filtering maybe. So let's say we want to see some basic aggregation function. So basic aggregation function with respect to this film table. So let's say the first thing that we want to basically test here is the average. We want to check the average rental cost, or rental rate rather, or the average length of the movies, the films that this company acts. So what we can say, select, let's say select title. Just want the title of the movie, the year of release, title, the release year, that is, and the average. Average length. Average length, which is this column that we want. Average length of what movie or film rather. Average length. Let's say average length as want the average length column to be renamed as real length. I did not make mention of the alliance. It's a real length. From the table name is film. You can end here. You can also want to group maybe by replacement cost, or you want to group them based on rental duration. If you want to group based on rental duration, you just say group by duration, then you end your statement, then you execute. So let's see what the error is. Seems to have an error. It says the list is not a group. It says select this as this. So we want the length to be named this from film, group by rental duration. So let me quickly see what this. The aggregated query without group by expression. From film, let's say we group by rating. So the expression one of selection is not a group by close. Okay, so the reason why we are having these multiple errors is that when you are doing aggregation functions, you cannot group things by what you did not select. For instance, we have the table structure for film here. What our aim here is we want to have the average length of a movie, or rather a film. We want to have a title, the release year, and the average length. They are all column names for the film. Average length of a film from the film table, group by. So the grouping must be done based on one of these. You cannot group by something which is out of this what you have selected. It's like you want to group things and then the grouping column is not found in the system. So as well, if we want to group by rating, then we need to come here and add a rating. So add rating now. You can come here and say group. Group by rating. Because we have used rating here, so if you execute this command now, from film, group by rating, the command, the error says this is incompatible with SQL note. Okay, so you can see the error. So let's group by release year. So group by release here. Okay. Another constraint is the multiple value that you want to factor out. So instead of grouping them by display multiple columns, if you group them now by title, we want the average length, grouping them by title. Execute this, boom, you see. So the title of Academy Dinosaur, the length is what? This, the length. So this is the average length if you are grouping by title. If you are grouping by release year, then you replace this release. So see, it shows that what all the movies were shot, they were filmed in 2006. So that's why you have this average. So the average length of all the movies shot in 2006 is this size, this length rather. So as well, you may group by description. Anything you want to group, any column you choose to group them based on. You want to order them, you must directtly figure out the column name and then execute based on it. That this description, what's the length of the movie with this particular description, what's the length of the movie with that description, just like that. You will see that the average length is now based on the description. You can as well do based on renter, that you want to figure out the length of a movie based on the rental rate. Grouping, group by renter. So execute that, they give you. Yes, that is based on rent. Or rental rate is different from rental duration. So for rental rate, we'll have this. Yes, that is just one example of aggregation function. That's how aggregation functions do work. So in the next example of aggregation functions, you can use count. Yes, you can use count. So we can say select. What are you selecting? You may select the title, the movie titles. Let's say select title, then you count. What are you counting? You may count the order number. Or let's say you count this. If you count here, let's say you want to count let's just say you want to count the duration, the rental duration. For counting goes only with integers, you cannot count string. So we want to count the rental duration from film. And to count rental duration from which table? Film. Where we just want to make something complex, where the let's say rental duration, we have a specific rental duration that we want to count based on it, where the rental duration is greater, it's greater than, let's look the structure here, rental duration is greater than Good. Let's just say greater than 3. Greater than 3. Yes. Then we order now. Greater than 3, we group. What are we grouping by? We can as well, and if we can end the prompt here, say greater than 3. We execute this. They say what? Group by must be there. Reason, it is an aggregation function, so you must group by something. So in this case, we group by what we have selected, which is a title. So we say group. Group by what? Title. Let's see where the error is coming from. Good. That's it. So first and foremost, what are we achieving here? We want to count all the rental durations for the films which their rental duration is what? Is this less than or greater than? Let me propose this. That's around the corner again. Okay. Okay. So you see the result. The result of all the rental durations. Order group by what? By title. So based on the title, the rental duration is that. Based on the title, the rental duration is that. So that will be it for the class of today, and I'm looking forward to the next class. And if you have any questions, you can do well to send me, to DM me in the WhatsApp, and it will be best if you send it in the group, so that it may be a question that other students also have in mind and they will want to be clear about something. So you just send it to the group, so that maybe by answering, I will avoid answering the same questions multiple times. And that will be it. Thank you.